Hey guys, I know it's been a long time since I made a video, but I'm right in the middle of remodeling my house. I don't really even have an office anymore. I'm kind of working in the corner of my bedroom while all this stuff gets done. But I wanted to show you some stuff. Got some good FunBoard stuff coming up, and I made something with this, this is a FunBoard. No, that's upside down. This is a V1 FunBoard, so we're about to get some V2 FunBoards that everybody can get one if they want. But I made a server out of this, and it's a full-fledged server. Not full-fledged, but you know, it serves files, it'll serve pictures, it'll serve little applications and stuff like that. So I'm going to go inside into my dungeon. The corner of my bedroom is where I'm working now, and show you the stuff, but I probably will just show you the computer screen and all that. So let's see how this thing works, because it's actually pretty cool, and it works with EZIoT as a DNS server. So let's check it out. All right, sitting up on top of my construction dust covered computer is the server itself. So there it is. It's just a FunBoard V1. It does have an SD card in it, which holds some of the bigger files that it's serving. But it's just sitting there doing its thing, and you can connect to it, or anybody can. And there's somebody connecting to it right now. So sent out a few pages. So let's see what's going on. All right, let's pop open a browser here, and we're going to go to EZIoT.link /DNS / Clayton, because that's the name that I registered for this. Okay, so you heard the beeping. That's the server beeping over there, and this is the page that it served up. So this is an image which is on the SD card, so it served that image. This is the HTML, the rest of it's the HTML that's on the thing. Here's a little form, and if you hit this submit, then it actually goes to, when it submits it, it runs an application. So the server that I wrote will serve files, serve HTML, serve applications, that sort of thing. And if you look up there, way up in the corner, are you following that up in the corner? It actually is serving the favicon too. So there's a little image up there in the tab. Okay, so it'll do pretty much all the stuff that you want. Oh yeah, this is an application down here too. So every time you click this, like if we click submit, it's running several things. It's getting the favicon up here, it's getting the HTML, it's getting this image, and then it's getting this data, which is in a little data file. It's reading all that data and presenting that, and then it's also doing this count down here, telling of how many hits have happened since reboot. So the server that we're using, which you guys can get, will do all this: serve files, serve applications, and that's really all you need to do. Okay. All right, before we get to the actual software that I wrote that will do this, the server itself, or server software, let's talk a little bit about how the internet handles all of this stuff. I'm using the internet in quotes. Okay. Now remember, we put in EZIoT.link DNS Clayton up here, but instead now we have an IP address. That's because EZIoT is redirecting the traffic to my IP, which is this, and then my router is redirecting that to the FunBoard that is actually serving the pages, the web pages, the images, all that sort of stuff. So keep that in mind. Okay, so here is a simple drawing of the internet. So all of this part in the green, that's the stuff that's at your house. So you're going to have a router, and then you're going to have devices that are connected to the router. Maybe your desktop, maybe your tablet, your phone, and in this case it's the FunBoard, right? And then your house, your router, is going to be connected to this thing over here, which is the cloud, you know, the internet, so to speak, through your internet service provider. So they're going to provide you with a connection to the internet. They may actually provide you with a router. That's the way it is with me. I use my ISP router for my general network that I work in. Okay, so you'll be connected, and then your router will get assigned an IP address. So I just stuck in 123.123.123.123 for this example, but my IP address is actually currently this right here, 75.89.51.221. That's my current IP address, but it will change. Okay, so the internet itself, I mean, how everything is addressed works by IP addresses. So, you know, every device on the internet has the series of numbers that tell routers and all the stuff that's happening in the cloud up there that we don't need to know all how that works. Everything is working off of these IP addresses, these number series. So when someone's down here, let's say they're on the internet somewhere, and they put in google.com or EZIoT.link, they don't actually go straight there. They first have to go to this little server up here called a DNS server, which is Domain Namespace System server. And the Domain Namespace System or DNS server, it takes the name like google.com or EZIoT.link. Let's use that because I know that one. It takes EZIoT.link and it maps it to the actual IP address. So this is the IP address of EZIoT.link. So if we popped open another window and put that in the browser, bang, there we go, we're at EZIoT.link. Now your browser does this automatically, so if I just put in EZIoT.link, then it's going to go to a domain name server or a DNS server, and it's going to do all of that for you and find the IP address and take you there. Okay. So what's happening with this whole system is that the FunBoard runs the EZIoT software, and it connects to EZIoT, so it goes onto the web, connects to EZIoT, and it tells it, hey, my IP address is this, because it will know it, and my port is this. We're using port 80, which is standard HTTP port. So it tells EZIoT that stuff. And then when EZIoT, and then your FunBoard says, use Clayton as the link word. So EZIoT then sets itself up as a router, or you might say a port. Well, I don't know what you would call it. It's kind of like a dynamic DNS service, because what happens is once EZIoT knows where your FunBoard is, it knows this IP address and this port. Then what's going to happen is when someone makes a request to EZIoT DNS/Clayton, then it's going to know that it's going to reroute the traffic to the router here. Okay, so that's what's really going on here. The FunBoard connects to EZIoT, tells it where it is, and then when someone else makes this request to EZIoT, then EZIoT will just link it to the address that it knows where the FunBoard is. Okay, so that's basically what's happening. Register, and then when someone connects here, it sends it to here. And that way, if your IP address at your house changes, then you just have to re-register, and then the same person can, hit the EZIoT link again, and it will come back to your router. Okay, now, in order for all this to work, though, we have to do something. We have to do two things inside of here. and they involve your router. And it'll be different for different routers, but usually you can connect to your router using HTTP. And then you can set these things up. So the two things that you have to do. So your router creates a sub network, okay, a local area network. It's like a mini internet, but it's below your router. And it will assign IP addresses to every device down here, so that so normally what happens is you make a request and it goes through the router. Then when the request data comes back, then the router will send it back to you instead of sending it to another device. That's why it gives it an IP address. So this is a typical IP address, 192.168. That's for households. And then 254.11, that's a typical, the way a device would be addressed. But the thing that you have to do is the router always has to know where to send it, where the FunBoard is and where to send stuff. Because it's trying to send general requests. So instead of sending just returning a request that came from here, it's just taking a general request that it's never seen before and needs to send it to the FunBoard. Okay, so this is what you got to do. DHCP reservation. That's the first thing you got to do. You have to tell your router that anytime the FunBoard connects, I want you to give it the same IP address. So maybe excuse me, maybe you want it to give it, this address. So every time this board connects and you see the MAC address from this board or the ESSID name or whatever you want to call it, whenever you see that, go ahead and give it the same address. Okay, that's important. So once you do that, then you can do this port forwarding. And what that says is if there's a new incoming request on port 80, then I want you to send it to this IP address on port 80. And that way, something that normally your router, it works as a firewall, blocks everything that comes in so that it doesn't know about. So when a new request comes in, if it's on port 80, go ahead and send it to the FunBoard. So those are the two things that you have to do. So reserve this IP address or any IP address for the FunBoard. And then once you do that, set up port forwarding so that when a new request comes in, your router will send it to the FunBoard on port 80. Okay? So that's pretty much it. That's how all of this stuff works together. So the software, the EZIoT software, will handle sending it up. You just say, I'm going to work on port 80, and it will send all that stuff to EZIoT for you. Okay? And then the server will be listening on the FunBoard for anything that comes in on port 80, and it will respond to things coming in on port 80. So that's how it works. Alright, now let's get into the software. So since we have EZIoT already up here, let's just start there. So we're starting at EZIoT, and we're going to go to the documentation on GitLab. Alright, so we are interested for EZIoT in this thing right here. Okay, locating a device on the internet. So that's what we're going to use the EZIoT for, is to relay to where we are. Okay, now of course the first thing you've got to do is get an account, because this is not going to work if you don't have an account. It has to know who you are, and you have to be able to register your micro or your ESP32 or whatever you're using, FunBoard or whatever. You have to be able to register that up there. Alright, so go through this and get your credentials. Alright, and it'll give you a key and a secret and a version and all that, and then you can use that to set up, or to sign in. Okay, and then we jump down here to dynamic DNS. Okay, and what you're going to do is use this function, EZIoT.setDNS. Don't worry about HTTPS. I'm not using that. We have to put the port in, so I'm using port 80. Don't worry about that one. Now your DNS ID, this is the name that you want to use for your link. So your link will be something like this one right here. This is mine, okay, EZIoT.link DNS Clayton. So this is my DNS ID. So you can put one in there and get one for yourself, okay? Now, if the ID that you ask for, so you're going to get an ID back, but if the ID, this is what this talks about right here, if the ID that you ask for is already taken, then it's going to give you a unique ID. It's just going to add digits to the end of that ID, and it'll give it back to you. Okay, and then you can always use afterwards EZIoT.getDNS to see what a DNS ID has been assigned to you. Okay, now once you have your DNS ID, it will stay attached to your account. Unless you use this down here. So don't use this down here. Just keep your DNS ID, and then you don't have to keep giving it every time. All right. But you can just put it in there if you want. But anyway, and then so this sets you up. So once you run this and you get a DNS ID back and all that kind of stuff, it sets up EZIoT to start forwarding to your router. And then if you want to stop that, then you can use the unset right there. Okay, and then of course this just deletes all data. You don't want to do that. Okay, so just read through that. Lots of instructions right there. Okay, so now let's go back to Clayton's PCB shop. We're not going to do EZIoT anymore. We're going to go to MicroPython, and where is it? There it is, microserver. Okay, now look, this is the exact code I use to run the beaker server that we just looked at. It's running on a FunBoard V1. This is, I mean, exactly it. So here's these are the documents. I mean, you know, this is the stuff that we're serving out of the htdocs folder. So there's, you know, the beaker picture, the beaker favicon. What else do we have? Here's, you know, an HTML page. This is the base HTML page that we're using. It's got some CSS formatting and stuff like that in there. And I also have this robots.txt, and this file, if it's present on your server, then it tells web crawlers and that sort of thing not to mess around with your site. Okay. All right, back here we have let's see, REPL-ACE. That's what we use to load files, and then we have our main and microserver itself. So let's pop open microserver. There's only a few things that you need to know there. Okay, so lots of notes and that sort of thing. And, you know, basically if you have a static file in your htdocs folder, it will serve it, okay, like favicon or whatever. And then if you have a path that starts with app, then it will run the application script. And we can change that, so I'll show you that in a minute. Okay, so so here's the server class itself. There's a few variables that we can change. We can tell where our htdocs is and different things like that. Okay, but really the things that we need to know about are these right here, and these are the functions that we can redefine, and we will in our main script. Okay, so right now if something starts with app, then it's going to go here and you're just going to get a web page back that says the application's not defined. Okay, and then but we'll redefine this so that when we ask for an app, it does the right thing and gives us the right kind of data. And then every time a client connects, someone connects to your server, this function gets run. And so we'll use this to beep a beeper and to turn on a micropixel. And then when a client disconnects, then this gets run, and we'll use it to turn off the micropixel. Okay, the rest of this is just all the server stuff where where sockets are being opened, and then client sockets are being opened and served out, and you know, a static file serve out. Here's the application being served out. Stuff like that. Here's your file server. This is interesting. So these are the file types that I have defined that it will serve out correctly. The rest of them are just going to be served out as application octet stream, which is just binary data. Okay, and then you know, it handles this is for your URL quotes, you know, where they encode the URL. Okay. All right, that's all we need to know about microserver right now. When we look at main right here, so remember that main gets run automatically when your device boots, your ESP32 boots. Okay, so here's our main file. You have to set up your network because you have to connect to Wi-Fi. That's just a given, right? You have to set up EZIoT, your secret, your key, and your DNS ID. You got to put those things in there so that it can set up EZIoT for you. Okay, and then we're importing microserver. Now you don't have to run this on a FunBoard. You can use a regular ESP32, but you just have to pay attention to this thing because in this main script, no problem with microserver, but in main we are using some functions of the FunBoard, right? So this just tells you which ones you need to redefine and which ones you need to that you can do away with. Okay, all right. So here is the class that we're going to make. Now we're going to call this down here when we start the server, right? There it is. So we're building a class that we're going to run, and we're using microserver as the base. So we just imported microserver here, and then we're using it as the base, and then we're just going to redefine these variables, right? So we're telling where our htdocs folder is, and I'm using the SD card. We're telling where the guest file is, so this is just a comma separated values file that holds the list of people that have signed in. Okay, and you know, how many guests do we want to show, how many guests are there total, and when microserver loads, if it knows where that CSV file is, it will count up all the guests that are in the CSV file. Okay, but then here's the critical thing. This is client on. This is what gets called when we connect. Now we are redefining that here. Okay, so it exists here, but we're overriding it in our class, and we're going to tell it to beep the beeper and set the volume at half, and then we're going to tell it to turn on micropixel 0 and turn it on, make it red. And then when a client disconnects, we're just telling it to turn all the pixels off. Okay, and then this is a little thing, this is just a little function that makes a basic web page. Okay, and you put some data in and the content in and the code string in, and it will make a basic web page for you. This is here's the head, and then let's see, and then it adds the content which is there, and that makes the web page. Okay, so we're just going to use that as a little shortcut. Okay, now here is the application itself. So when something comes in and it starts with /app/, we know that it's an application and it's going to get sent here. So you're going to get a dictionary of client data. It's just going to be, you know, key value pairs. You're going to get the client address, and you're going to get the client count, or a count from the server or from microserver. All right, and let's see what we're doing. So all we're doing, we're getting the options. So we're looking at the path info. So if the path starts with app, it's going to get sent here. So now all we have to do is look at the end of the path. So I'm splitting the path, I'm looking at the last item, and I'm calling that the option. Okay, here's the option. So if the option is page count, then I'm just make response. I'm using this make response, and I'm giving it the client count. All right, now that would be down here. See that? That's where the page count goes, right there. All right, So that's one option. Another option is guest. Now this would be if a guest is trying to register, okay? And then this is all the stuff that it does and how it registers a guest and whatnot. You can look through all that if you want. And then it once the guest is registered, it redirects to index.html. Okay, so that's all that's doing. And then here is the option to get a guest list. So that would be this right here. Okay, so it's going to build a little table and put the last 24, I think we said 24 guest. Where did we say that? Yep, it's going to put up to 24 guests and print it in the table right here. Okay, so we're back to where we were. Here's the guest list. It reads the data, it makes the table, and then it sends it back. It uses the make response function above and sends it back. And then this is what we send if the function is not there. So we don't know what the function was. Whatever the option was, we don't recognize it, so we send that back. Okay? So that's our entire server right there, just building on top of microserver. And then so here's where we instantiate the server. Okay? And then this is some extra stuff you can read through. It's and then here's where we're actually starting the loop. So we're making this infinite loop. We're putting it in a try statement so that it won't fail. Somebody just hit the server. And let's see. So we're connecting to the network. We're setting our clock. And we are registering at EZIoT. Okay. And then here's where we're starting the server. Okay. And then it's just going to run as long as it can until it crashes or until you do a keyboard interrupt. And then it will handle the keyboard interrupt correctly. And if you're using that commented out stuff, that's what this goes with. And then that's it. Okay, that's the whole thing. So that is all the software that is required. I know this has been a long video, but that's what it takes, the pieces that it takes to put this whole thing together. So I hope you give it a shot. At least go register on mine. And if you get one running, you tell me about it, I will come and register on yours. Okay. Okay, so that's pretty cool, I think. I've made some servers with ESP32s before, but I've never really made them that would serve images and all that sort of thing. So you can do it. You know, you could put a graphing application on there, which I'm working on one right now that uses SVG. Just getting started with it, but I'll have that available for you guys. And you know, you can set up an IoT device that can serve its own charts and that sort of thing. So anyway, I thought it was cool. Hope you guys enjoy it. Later.